as far as I am concerned, I never take any demo type class. I take serious class only. But limited time and limited, what you can call is limited time and limited parts. So I already selected, the chapter is selected, connected with displacement method. I think you all got the, what you call it as, those sheets, some 10 pages. You got it. I will mention question number. You got that 10 pages taken print out? Have you taken print out? I think from civil applied programs, it is given to you. Have you got it? No, have you got it or not? Those who are participating, you should have the questions with you. Have you got it? Yes, okay. Otherwise, I will dictate the question. See, now, remember, somewhat limited part. One part I will cover is regarding fixed beam. I will put formulas here. Fixed beams. That is beam which is fixed at both ends. See, you actually, after the class seeing recording, you write everything. I will call left side as A, right side as B. Everywhere, length of beam, I will take L. This is a common part. Common. Beam fixed at both ends. Both are fixed ends. Length L. Then also not required now. See, one by one, you have to consider fixed end moments. Fixed end moments. That is, for the fixed beam, FPMs, I write here, for loads. This is for loads. For couples, separate formula is there. That all we can't cover. Exam point of view, what all they are given in those things I will cover. For loads. See, fixed beam, first remember, any type of load, I'll put random this way, or I'll do one thing. They can give point load, UDL or UVL, anything, anywhere, randomly. If this is A, this is B, the FPM here is anti-clockwise. FPM here is clockwise. See, the reacting moment anti-clockwise here, clockwise here, for loading. I am telling for loading. In general, this you can understand very easily. 1 minute. See, actually, if you remember, in the regular class, I explained much more. See, this is a beam. It's a simply support beam. This is simply support beam. Okay. See, fixed means, see here, how to fix here. You require anti-clockwise here. You require clockwise here. Or, see, the fixed end moment will hog the beam. See, this way. So, remember, FPMs are, here it is anti-clockwise, here clockwise for loads. Which load? Any type of load. Now, I will write standard formula which you require today. Say, 1. You should write everything, you should write by words. Fixed beam subjected to central point load. See, W. This is L by 2. I already told length is L. Length is L. This is L by 2. Then this FPM and this FPM you require. The FPMs are WL by 8. This also WL by 8. Both are equal. Both are WL by 8. Okay, then next formula is fixed beam with the eccentric load. See, this is L by 2. L by 2. Eccentric load W. Eccentric means anywhere. Let it be A from here and B from here. Total length is L. This FPM and this FPM you require. See, central point load direct formula, WL by 8. Eccentric load formula is, suppose I want here, see now, only once I will tell, load W, distance from here to the load, A, into other distance to be squared, B squared. Remember, When you want moment here, load into where you want moment from their distance into other distance square divided by L square. Same way, if you write here, load W, distance from here to the load, B, other to be squared, A square by L square. Next, if fixed beam is subjected to UDL, see, UDL, W per unit length, it is intensity of load. You should, that much common sense should be there. W per unit length means it is intensity of load. How much per unit length? Like kilonewton per meter. Span L. Again, symmetry, both are equal. Remember, this is central load is WL by 8. UDL is W by 12. This also WL square by 12. Okay, then I will write next here. Suppose UDL is not full span, only half the span, starting from here up to center. This is actually the question is there, L by 2. Again, it is W per unit length. Or it can be like this also. See, it can be like this also. L by 2 from that side. That is fixed beam with UDL of intensity W per unit length starting from one end and extending up to center. Then the formula will be again anti-clockwise, clockwise. This is same. See, loading means same. How to remember is for UDL, see, WL square guaranteed. WL square. Everywhere WL square guaranteed. WL square guaranteed. Then one into some number. Here number is 1 by 12. It is not 1 by 12. The numbers are 11. Number is 5 by 192 and 11 by 192. You should know which number is where. How to remember? Don't by heart left side, right side. Where load is acting, that side effect is more severe. Here, load is acting on the left side. Therefore, tell the number here. Tell the number. See, by 192 guaranteed. Here also, by 192 guaranteed. By 192. Tell me answer. Load is severe on left side. Higher value should come. How much? Number on left side. First, think and tell me. Number on left side. Where load is more severe, higher moment should come. What is number on left side? You can answer the question. Left side 5. I just now told you are already there in earlier batch. So fast confusion. How you got idea of 5? I told where load is acting, that side is more severe. That side more severe means higher moment should come. 192 common. So here load is left side, there high moment required 11 by 192, other side 5 by 192. And if it is this case, load is severe on the right side. So here it is 11 by 192, here 5 by 192. Okay, now, then we have uniformly varying load. These are all standard formula they can ask. Uniformly varying load, where two cases are there. One case is intensity at the ends 0, maximum at center. See, this way. Both ends 0, center maximum, W per unit length. Then both moments are equal. The values are, this you have to by heart it, 5 by 96 WL square. Here also 5 by 96 WL square. Both are equal. Remember now, just to separate, I will put one line here so that left and right should not merge. Okay. See now okay thing. Now okay. Then or now see. Now Or you can have fixed beam. See, I write here now. Fixed beam with uniformly varying load. Here, 0 at the ends, maximum center. Here, 0 at one end and maximum at the other end. See, this way. So here, W per unit length, intensity. It is 0 here. Or it can be like this also. See, don't buy at left and right side. It can be like this also. W per unit length. How to remember? This is 0 at the ends and maximum at center. This is 0 at one end and maximum at the other end. So, here also, the formula guaranteed is WL square. I am making it easier for you. WL square guaranteed. The expression for moment is in terms of WL square. This also WL square. Now, I told for partial UDL, one number is 11 by 192, other number is 5 by 192. How to remember? Where load is acting or where severe load is there, their higher moment. Here, it is not multiplied, it is divided by a number. See, divided by a number. So, numbers are 20 and 30. Now tell me, where moment is more severe or where loading is more severe, high moment should come. Tell the answer here. See, one of them is 20, other is 30. Here, tell me, answer. Where load is more severe, that side more severe. So, right side should come more. What number here? Left side number. Where load is predominant, their high moment should come. What is number on left side? 11. 11, yav 11. You are telling old answer. Number on left side. Do not buy at left and right. What is number on left side? 30, correct. If you remember, when I was taking class, first you told 20. Do you remember it? You first told 20. Do you remember it? Blindly, you first told 20. Because lesser number. Remember it or not? You don't remember. You remember it. I told 3-4 times there. Be careful. See, here it is multiplying by 11, multiplying by 5. Here it is dividing number. So, here less moment should come. Load is more severe here. So, here high moment 20. Because divide by 20 will give higher value. Here divide by 30. Here load is more severe on left side. So, high moment should come. This is 20. This is 30. Over. These are the expressions for FEMs for standard loading, which usually they ask in examination. Other formulas are there, not required. Then there is one more case. I write here. One more case. Actually, another case is there due to couple. Today's class, I will not explain. In the regular class, I will explain that one. See, when I take subject later in the group, when the classes are started, or when I take the class for you, then I will tell you about couple also. But this time, that much time scope is not there. Because some sensitive, you have to be careful for couple. Now, one more question, very popular. That is called the important settlement of support. Settlement of support, or also called sinking of support or raising of support, support movement. Fixed beam, two cases are there. See here. This is fixed beam. You should write here. A fixed beam here, dotted line. Or this is fixed beam. I'll put dotted line here. Dotted line. Span L. By chance, right support comes down. It comes here. Elastic curve will be like this. Zero slope. This will remain there only. Or left support comes down. Elastic curve like this. Now, there will be end moments. There will be end moments. See, first of all, remember, you should make a note. When you consider loading, one side is anti-clockwise, other side is clockwise. But due to settlement of support, see, this comes down by delta. See, delta, common for both. With respect to left hand, right hand is down by delta. Or you can tell, with respect to right hand, left hand is up by delta. It is relative. Same here, see. With respect to left hand, right is upper side by delta. Or with respect to right hand, left is downside by delta. You have to remember, moments are equal. Values are common. 6 EI delta by L square. See, 6 EI delta by L square. This also 6 EI delta by L square. This also 6 EI delta by L square. But important is direction. You should make a note. Once again, I will tell you. When you consider loading, see, I am telling third time. One side anti-clockwise, other side clockwise. But here not that way. Both are anti-clockwise or both are clockwise. You should, after the class, write it. How to remember? See, what you do is, you take the beam here, tilt it. See, easiest way. I cannot go too much behavior. Actually, technical reasons are there. If I keep on telling technical reason, demo class will become theory class for half an hour. Now, see, this way. You tilt the beam, tilted. In the tilted position, you first go to tilted position. See what moment you require so that you should turn it back to one side original. See, this is tilted, inclined. See now, what moment required at both ends, see, so that it will once again become horizontal. Tell the answer here. It is tilted like this. See, fixed end moment is the reacting moment. So, since it got tilted here, tell me answer. What moment you require to bring back to horizontal position? Tell me. What do you require? Since, see, it is tilted this way. So, what moment is required to bring back to once again horizontal position? Anti-clockwise. So, make a note. Anti-clockwise, anti-clockwise. See here. This is tilted like this. Now tell me, you hold anywhere you want. You hold this way. Tell me answer. Tilted here. What moment is required to bring back to horizontal position? What? As I do examples later, this I will not explain. What do you require? Already explained just now. What do you require now? You are not answering. It is clockwise. Leave it because you are not answering. Okay. These are the standard cases you require. Okay, leave it now. Now, within the available space here, I will first cover what all FEM questions are there in the examination there. Okay. Oh, sufficient. See now. I will tell you one by one question. Question number. I see, I got limited option now. I'll go further. Question number, it is not clearly visible, 5. I'll go to question 5. There, the sketch given, question 5. A fixed beam is given this way. Fixed beam given of length 5 meter. Of length 5 meter. And then there is a point load of 10 kilonewton at 2 meter from left end. 10 kilonewton at 2 meter from left end. If that is 2 meter, this will become 3 meter. That much common sense should be there. This is A and this is B. Then they told, see, arrow mark they given. They told this is MFAB, moment due to fixity at AB. MFAB, this is MFBA. Remember, the fixed end moment they can call the either MFAB or M bar AB, etc. name. They want the answer of, for the given beam, what is the value of MFAB they want. They want what is MFAB is how much. Tell the answer fast. Tell the answer fast. How much answer? Where's the calculator? You tell me the answer, then I solve it. Try. Option is there. There are some options are there. Leave the options. We will get the answer there. What is the answer? Answer is, see, options are A plus 7.2, B minus 7.2, C plus 4.8, D minus 4.8. Tell the answer fast. See, starting question only, I will tell you what happened. No, option A, B, C, D. What is the correct answer? Starting question only, see, I am exposing their weakness. There is some weakness or blunder committed by examiners. I openly tell it. People sometimes, without knowing basic concept, they set the question. They don't deserve to set it. Answer is what? One is plus 7.2, other is minus 7.2. Tell me now. What is the answer? Answer is A, because nodi, your MFAB, they want MFAB in anti-clockwise direction. Yes, we know that it is anti-clockwise only. Therefore, answer is, see here. Which formula? This formula. This formula, right there. Load. I want you write formula first. You write here. You put some number here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The formula to be used is which one? Fourth formula. Use formula number 4 is 10 into 2 into 3 square by 5 square will come 7.2 kilonewton meter. So this is the correct answer. Clear now? Correct answer is 7.2A. Clear or not? 7.2 is plus 7.2 is the correct answer. Clear? Correct answer is plus 7.2. Now, I will tell you what they will tell. The most probably in the options, in the key, what do you call it? Key answers. In the key answers, most probably they told B is correct. Most probably chance. They told B is the correct answer. I will tell them, if he tells B is the correct answer, the person does not know basic mathematics. Wrong. What he will tell is, see, it is anti-clockwise, so minus 7.2. You should tell them, who want clockwise, anti-clockwise sign convention? You want MFAB. You told MFAB anti-clockwise here. You have marked it anti-clockwise. So it is anti-clockwise. So that is wrong. I know 99% in the key answers, they will tell B. It is utter nonsense. Answer is A. If they want B, they should not give direction. Then okay. Tell why. Then it is anti-clockwise 7.2. Then also nonsense. Sign they should tell. Okay, usually in India, we take anti-clockwise positive. So he will tell it is anti-clockwise. So minus 7.2. In that case, his answer is correct. But once he marks anti-clockwise here, and then he tells minus 7.2 is the answer, he is not fit, not to set the paper, not to go near the examination hall. I should be very harsh for such people. People are there. Okay, leave it now. You may think it is a harsh comment. I have seen those things. These things I have seen. Now, next question. Next question will be question number. Ready? In the beginning, one question is there. I skipped it. Now I am doing it. Leave question. Yes. Question number 4. Be very careful. Question number 4. They told a fixed beam where there is an inclined load W at A from here and B from here. Span is L. They told span is L. The angle made by the W, this is theta. They want what? Fixed end moment. See, they want fixed end moment at A is how much? A. See, previous question, if they ask FEM at B, answer is 10 into 3 into 2 square by 5 square. Okay. They want FEM at A. Now see, first you write the question. Option you will see later. Now, remember, this is an inclined load. Tell what you have to do. If inclined load is there, first you have to resolve the load. See, this load will have a vertical downward component. See here, a load acting like this. If the will have a horizontal component and vertical component. Your load is W. They told angle with vertical. So remember, if the angle is given to vertical, the rule is that component with which angle given is always cos. This is W cos theta. This is W sin theta. Why? Horizontal is sin, vertical is cos, because angle given with vertical. But remember, in the class I told, you always consider angle with horizontal. Okay, that also will do. If you consider the angle W, they told theta with vertical, with horizontal is 90 minus theta. Then the component is horizontal is cos, vertical sin. W cos of 90 minus theta, W sin of 90 minus theta. But you know that cos 90 minus theta is sin theta. So it is W sin theta. This is W into cos theta. So vertical force is W into cos theta. Remember, horizontal component is like this. Remember, for a beam, horizontal forces will not create any moment. It is an axial force. Clear? Horizontal force will not create any moment. It is axial force. You consider only the force which is perpendicular to beam. Clear or not? Consider only the force which is perpendicular to the beam. Along the beam is not required. Therefore, now, class is then. Class ಎಂತ ಇದು ಎಂತ ಇದು ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. Okay. Therefore, now W cos theta, see, they told this is A, this is B. This moment they want, that is W cos theta, W into A into B square by L square. Therefore, correct answer is option number, see their option. See, however, I am not bothered to see the option. Option A, WAB square by L square into cos square theta. No. B option, WA square B by L square cos square theta. No. Third option, WAB square by L square cos theta. Yes. WAB square by L square to cos theta. Option C is correct answer. Right. That's all. Now, next question. Next question is question number 6. Question number 6, next one. I am not removing anything because reference required. When I finish this FPM, I will remove it. If at all time is left out. Sixth question. Sixth question is, they have shown a fixed beam here. They mark this way. They told this is delta. They have shown this delta. Then they have shown this moment anti-clockwise, anti-clockwise. They told this is MA and MB. They want the value of what is MA and MB. What is MA and what is MB. You know the answer. See, it is this case. MA and MB both are 6EI delta by L square, 6EI delta by L square. So option, correct option is 6EI delta by L square. Both are correct. Over. So option A is correct answer. Option A, where they told MA is 6EI delta by L square, MB also 6EI delta by L square. Over. Next question. There's a question moment required. That all I can't take now. Then question number 5. I will remove this one now. Question number 5, I will not write on the board. See, what will be the end moment for a fixed beam with the uniformly distributed load of W kilonewton per meter square? They told W kilonewton per meter square. I don't know where that person is. W is not in kilonewton per meter square. What nonsense is? It is kilonewton per meter. Okay, excuse. What else to do? Such a common sense is not there. For a beam, load card, that is for slab. Kn per meter square load comes for surface area or when area is considered. Beam length considered. Anyway, okay, nothing can be done. And span L, they told answer WL square by 8, WL by 8, WL square by 2, WL square by 12. Yes, you know the answer. WL square by 12. Correct option is D. D is the correct answer. Enough. Now, there is an interesting question. Interesting question. Question number 3. See, you should have the sheet with you. If a point load acting at the midspan of a fixed beam of uniform cross section produces fixed end moment of 60 kN meter. See, there is a fixed beam. They are not told length. Let the length be L. A point load of what? 60 kilonewton. Okay. Center means L by 2. They told the end moment is, both ends are equal. They told fixed end moment is how much? No. They are not told point load. A point load, say W. We don't know what is the point load. A point load, we don't know how much point load. They told if a point load, say W, acting at midspan of a fixed beam is producing fixed end moment of 60 kilonewton meter. 60 kilonewton meter. They are asking then what is the fixed end moment if the same W is distributed for entire length? Tell the answer. What is the intensity now? They told you should write after the class. They first told, say a point load W. A point load W is acting on a beam. Okay. It will produce a fixed moment of 60 kilonewton meter. How much span they are not told. What load they are not told. They simply told a point load at center for a fixed beam produces FPM of 60 kilonewton meter. Tell me now, how you got this 60? This is WL by 8. Yes or no? Tell fast. That 60 is WL by 8. Correct or not? Tell fast. See the formula there. That FPM is WL by 8. Yes. Leave it now. Now they are asking, correct, good question. What is this question? If the load W is spread for entire length, tell the answer. You should write a note after the class now. This W, if you spread over entire length, tell me what is the intensity? W what? By how much? If the same load is spread over entire length, tell the intensity. W by, bega. W by. They told that point load is spread for entire length. Then what is the intensity? W by. Load W is spread for entire length. So what is the intensity then? How much load per length? W by L is the intensity. This is the intensity. Okay. Now FPM is what? FPM, that is our small w. Clear? That is our small w. Intensity, small w. Now FPM is WL square by 12 equal to WL square by 12 is how much answer? W is how much? W is W by L intensity into L square by 12, or L and L will cancel. It is WL by 12. Now do one thing. WL by 8 is 60. Therefore, tell me what is WL? Earlier you got WL by 8 is 60. So what is WL? Tell the answer. You require calculator for that one. What is W into L? If earlier they told WL by 8 answer is 60. So what is W into L? This also you can't answer. When WL by 8 is 60, what is WL? Oh, this is very bad. You are attending for no purpose if you do not respond that much also. When you came to my class, you should at least be little attentive. Not simply 480. It is 480. So substitute that 480 here. So WL is 480 by 12. What is the answer? 480 by 12. Because using the previous data, we got WL equal to 480. Substitute here. 480 by 12. How much? 40 kilonewton meter. 40. See, correct answer is 40. They are given option A 20, option B 30, option C 40, option D 45. So correct answer is option C, that is 40. Okay, over. Good question. Now, next question. There are a lot of questions on fixed beam. Idayitu. This is also over. I'll tell you the next question now. That also over. Nodi, question 6. I will solve question 6. Good question. Actually, see, make a note. Before question 6, they asked question 5. Question 5 was a fixed beam of span 5 meter subjected to point load of 10 kilonewton at 2 meter from here. If that is 2 meter, this is 3 meter. They want this FPM. Tell how much answer you got. They are asking you this FPM. You already know the answer. Tell the answer. 10 into 2 into 3 square by 5 square. What is the answer? You already got earlier. Question 5. How much? 7.2 you got. This FPM is 7.2 right here. Already, this is answer. Okay, now this is question 5. Question 6 is for beam shown in question 5. Question 5. What is shear force at A? What is shear force at A? Notice. Can you see the question? Question 6 is for the question above question. Question 5. What is the shear force at A is the question. You should know one thing. Shear force at support. You should know. What you should know? Shear force at support is what? Begadi. Is nothing but what? Shear force at support is nothing but. Fast. You should have common sense, that much. Shear force at support is nothing but. Is nothing but what? You should know that one. At the support for a beam, for a single span beam, shear force at support is no idea now. Shear force at the support for a beam is. What is this? Never heard of these things. If you do not know all these, I don't know what to tell. Shear force, this in the regular class I told hundreds of times, not once. Hundreds of times I told in the regular class. Here it is not same group, it's a demo class, so I should explain. Shear force at support is what? This much time. All people, those who are there, nobody is giving any comment. What is shear force at support? 0. Very good. Abba. This is outstanding knowledge. What is this? Past B telling 0. Shear force at support is vertical reaction at the support. Reaction at support. So, if there is a vertical reaction here, VA, then shear force at A is equal to VA. Clear? Shear force at A is VA. Okay. 0. It's very easy to tell 0. Very good. Shear force at support is VA. Therefore, they want the value of VA for this question. See what to do. You should write all I am telling you should write. We already got this moment 7.2. Now you require this moment also. Tell this moment how much? 10 into 3 into 2 square by 5 square. What is the answer? Answer fast. I want this moment also because then only you can find reaction. That is 4.8 kilonewton meter. Now, what you require? You require the value of VA because question paper they asked what is shear force at A? That is VA. If you want VA, take moment about which point? A or B? Tell me. If you want VA reaction, I should get the value of VA directly. Take moment about A or B. If you want VA, you should take moment about other support. Which point? See, if you take moment about A, you are getting VB value. You will get the value of VB. If you want moment at A, take moment about B. Sigma M about B0. Take clockwise positive. See here. Moment about B. Plus VA into 5. Plus VA into 5. Minus 10 into 3 anti-clockwise. Then now clockwise positive. Minus 7.2. No distance. Plus 4.8. Equal to 0. Therefore, you get the value of VA. Tell the answer VA. There are 4 options there. Options are 5.52, 5.52 up, 5.22 down, 6.48 up, 6.48 down. What is the answer? 5.52 up, 5.22 down, 6.48 up, 6.48 down. What is the answer? Tell the answer fast. Calculate. Who gives this answer? $30 plus 7.2 minus 4.8 divided by 5. 6.48. Answer is 6.48 kilonewton. So options are 6.48. Options are 5.52 up, 5.52 down, C is the option is C is 6.48 up, D is 6.48 down. Tell me correct answer. 6.48 up is correct or 6.48 down is correct. What is the correct answer? Correct answer. 6.48 up is the answer. Okay, tick that answer. But if I am in front of him, I will tell you does not know what is shear force. Shear force you cannot tell up and down. Nonsense. You should ask reaction up and down. Shear force is not direction based. It is nature based. I will tell him, don't know the basic concept, setting the question. Okay, done. What I can do? Correct answer. They want 6.48 up. I should be harsh. For such people, I should be harsh. Okay, then. Question number 7. Beg madbekiga. Question number 7. They give question number 7. They told a beam here. Beam with uniformly varying load like this. W per unit length. Okay, then they told this is MFAB. This is MFBA. You know the answer. See, where is the answer? This case, MFAB is here, MFBA is here. They want what? They want not MFAB. They want MFAB divided by MFBA. Tell the answer, Bega. Options are A 0.33, B 0.67, C 1.5, D 1.33. Bega the answer. They want ratio of this one to that one. That is what they want. WL square by 30 divided by WL square by 20. Answer first. Which is correct answer? A, B, C, D. Which is correct answer? Sariyagi nodi. MFAB by MFBA. Yo, sariyagi nodi question. You should read the question correctly. Correct. C, MFAB is WL square by 30. MFBA WL square by 20. This by this they want. How it is 1.5? You are, see, this such a hurry, you are spoiling the question. Unnecessary, you are losing question. Tell the answer. This is WL square by 30. That is WL square by 20. So they want WL square by 30 by WL square by 20. It is 20 by 30. So answer is 0.67. Suppose they ask MFBA by MFAB, then it is 1.5. Clear? If they ask MFBA by MFAB, then it is 1.5. See, you are not serious. You are not concentrating. What they want, you should see correctly. Don't blindly substitute. Clear or not? Clear? If the MFBA by MFAB required, then correct. 1.5. Okay. Now, then I will tell next question. Question 8. Badabidi. Ille ide. They told this beam, E beam. this beam. They want what is the FPM at A? Illage answer. 11 by 192. They want FPM at A. 11 by 192 is the answer. That's formula answer. Other questions now. One minute. Okay. Now, one more question is there. This is regarding what? Regarding settlement question. Good question. I don't know whether the answer they are given is correct or not. Still, I don't know. Let me see. I'll solve the question. Maybe it's the last question. Sufficient. Because then if I continue further, I have to change the chapter. Changing of chapter means introduction required. No time to cover all. So 1 hour class, demo class. So it is, the question is, see now. Question number 11 I will solve and close the class. Actually, demo class means what? You should know how the class is taken. You cannot learn the entire subject by demo class. Demo class purpose is whether you are following the person who is taking class, he looks to be competent enough, or does he have good concept, or is he explaining properly, that to understand is a demo class. So, a fixed beam having a moment of inertia I. They told fixed beam. Fixed beam. They told, okay, this all I'll remove now, not required. I'll remove this one. They told moment of inertia is I. Unit what? I millimeter power 4. Okay. Because moment of inertia is always linear power 4. Span 3 meter. Span 3 meter. Settles 1.5 centimeter at one end. Any end at one end. Modulus of elasticity E is 2 into 10 to the power 5 Newton per mm square. Or they can tell MPa. Remember, both are same. Then the bending moment at support is A 4I by 3. Bending at support, remember, in unit they told, in Newton millimeter. They want bending moment at support in Newton millimeter is A 4I by 3. B I. C 2I. D 3I by 4. Okay, solve. First of all, remember, make a note. Bending moment at support is nothing but fixed end moment at support. Therefore, for the question, fixed end moment, see, they want what? They want bending moment at support equal to fixed end moment at support. Direction, they are not bothered. So it is 6 EI delta by L square is the answer. You know it already, see. When the settlement is there, it is 6 EI delta by L square. Now be very careful. They want the answer in Newton millimeter. So what you do? Substitute everything in newtons and millimeter. So answer is 6 into E. E they told 2 10 to the power 5. I they told I only. Delta is 1. See, delta, this is your delta. Delta is 1.5 centimeter. Be careful. Delta is 1.5 centimeter equal to what? 15 millimeter into 15. See, delta in millimeter. Divided by span, they told 3 meter. They told span is 3 meter equal to 3000 millimeter divided by 3000 whole square. Tell the answer. A, B, C, D. Tell the correct answer. Among A, B, C, D, which is the correct answer? Bega. A, B, C, D. Correct answer. Correct answer. Which is correct answer? Correct answer is equal to, nodi, ella simple agi, it becomes 2 times I. Therefore, what is the answer? Yes. 2I is the correct answer. This is the question. Okay, now let me see if any other question is there for fixed time moment. Chapter I cannot change because time is not there. Plenty of questions are there. Lot of questions are there. You work out that one. One nimisha, let me see. If any question I can solve now. So with this much knowledge only, no extra knowledge. I think I saw one question. I don't know where is it. One question I saw. I thought I can solve it. Yenadu? Question 15. 15 irbeku. Okay. One question I solve. Question 15. Good question. Actually, this question is little high level. Okay, leave it now. Notice. Question 15 I will solve. Question 15. They told for a fixed beam, see the question correctly. Option later. Let the span be L. A load W anywhere. Load W anywhere means A from here and B from here. Remember, if they tell central load, you should take L by 2. See, they told due to some point load anywhere on a fixed beam. Anywhere on a fixed beam means what? You can place anywhere. So randomly A, B. See, this is FPMs. They want what is sum of FPMs. That is at both ends. Numerical value. No sign required. See, this is anti-clockwise, clockwise, sign is not there. What is, suppose I call this as MA, this is MB. They want MA plus MB is how much if they told something else there is how much if it is, the question is, if, where is that if? I saw that if where? If maximum free BM is M. Okay. Tell me. First you write MA plus MB equal to, you know, MA equal to what? WAB square by L square plus WBA square by L square, or equal to WAB by L square into what? A plus B. WAB square by L square plus WBA square by L square is WAB by L square A plus B. But you know that A plus B equal to L, or equal to WAB by L square into L equal to WAB by L. Clear? This is clear. If you add those two, WAB square by L square plus WA square B by L square. You get answer WAB by L. Tell me, clear or not? Vega. Is this step clear? If you add the two values, see, you take WAB by L square outside. A plus B is L. Is this step clear? Okay. Then they are telling maximum free BM is M. Anybody can tell what is free BM? Free BM is bending moment for simply supported beam. You should know it. You know, for a simply supported beam, load W, if you place A here and B here, the maximum BM is WAB by L. Oh, both are same. So whatever sum of FEM came equal to maximum free BM. So answer is what? M. Correct answer? Correct answer is M. Clear or not? Option they told. ಎಲ್ಲಿದೆ ಕ್ವಶನ್ ಅದು? ಅದಕ್ಕೆ ಆಪ್ಷನ್ನೇ ಕಾಣ್ತಾ ಇಲ್ಲ. ನೀವು ನೋಡ್ತೀವಿ ಆಪ್ಷನ್. 2m, m by 2, m and 3m. Correct option is m. Why? Sum of FEMs you got same as maximum free BM. They told maximum free BM is m ಆದರೆ what is sum of these two? Sum of those two is equal to m. ಆಯ್ತು ಬಿಡಿ. Little concept question. Okay, now new part I cannot take because see, maximum time told is 1 hour. If required, I was told little more time will do, around maximum 15, 20 or 30 minutes. But I first thought I will cover something else, but I did slowly here. So if I go to any new part now, not possible. Why? You require introduction to that one, like fixed beam. By the time I give introduction, class will be over. Therefore, I will go to close the class now. Anyway, demo class. Purpose is to see or for you to decide how competent is the person. Clear now? What all I told, fully clear today? Today, what all I told, everything is fully clear? At least tell that much. Okay, that's sufficient. Okay, I will close now. Thank you. Those who are in the group later, we will meet in the classroom. It is going to be offline class most probably. So those who are there, those who join the group, I will be coming and taking offline class in front of you only. Okay, thank you.